Hello again, ACST1052 students. Doug Fletcher here for the third in our series of videos on doing simulations in Excel. So I'll share my screen and we'll get on to it without further ado. So on this Excel worksheet, we're going to be considering generating random samples from a discrete distribution that does not have any particular mathematical form. So there's no mathematical formula for the probabilities, unlike the binomial distribution or the negative binomial or the various other ones. This one does not have a mathematical form, and all that we have to describe this distribution is a set of probabilities over here. Okay, so in this table, we have x values, so it's a discrete distribution, x values from 0 to 5, and these are the probabilities that attach to them. And as any time you're given a discrete distribution, you should immediately check that the probabilities do in fact sum to 1, which they do here. I put an automatic total in there. So this is a valid probability distribution for a discrete variable. And as I've indicated before, when we're doing simulations for probability distributions, we need the cumulative distribution function, and that's what I've tabulated in this column here. So in Excel, it's a very simple formula. We simply take the value and we accumulate the probabilities in each case. Okay, so the first one is 0.26, then we add 0.35 to get 0.61, then we add 0.23 to get 0.84, and so on. And so we simply put this formula in there, and I've got this n function in there, so it takes the previous row and it just interpret anything that isn't a number, it'll interpret it as 0. So I put the n function in there simply for the sake of this first row. And you copy that down, and you should always get 1 for the opposite, the very last valid value, so that the values must be no more than 5. So values you obtain can't go as far as 6, so you are certain to get a value that is less than 5, or less than or equal to 5. Now, how would we do this this simulation in Excel? Well, just as a quick refresher, let's have a look at how we were doing this in our earlier case for things like the binomial distribution. So I've got a, I'm just going to put up my discrete distribution display here, and it could be any discrete distribution. So I'm just going to choose one here that's not too complicated. Oh, that's getting too many values. I just want something with only a few values to it. That one might do. Okay, so let's use that, and I'll just put that up so it's nice and big. So what we have here, and ignore the fact that it's a negative binomial, we're not interested in that. We're simply revising how it is that we are going to simulate this distribution, and just simply taking into account the probabilities, not the mathematical function or anything. So from our random variable on 0 to 1, we're going to assign the random variable value 0 if the probability that we get, the random value we get, is up to 0.21 there, which is the height of the first probability there. And if the random value we get bumps into the second riser, we're going to assign the value 1. And if it bumps into the third riser, we're going to assign the value 2. Okay, so this depends very closely on the cumulative distribution function. Now let's go back and see how we can get Excel to help us here. So what we're going to do is we're going to say, if we find our random value is less than 0.26, we want to return 0. And if it's more than 0.26 but less than, say, 0.61, we want it to return 1, and so on. Now, Excel gives us a way of doing this using the VLOOKUP function. And what we can do, we can give it a value to look up. So that's our rand array value there. And we can give it a table to look up. And it might have been tempting to actually use 0.26 and then look up 0, or 0.61 and then look up 1. But we have to take into account the way Excel does an approximate match. Okay, now this is the thing, because we don't want to look up exact values here, because the chance of getting exactly 0.26 is practically 0. The chance of getting exactly 0.84 from a random value is practically 0. So we do need an approximate match. But the question then is, exactly how does Excel do its approximate match? And the point is that if we do an approximate match, that is, we either leave out the last argument or explicitly set it to true, which is the default value. Okay, so we can, I might just type in true here so we can actually see that's what it is. But if you leave it out, then true is what's assumed. So if we put that in, then what Excel is going to give us is it's going to match on the largest value that is less than or equal to the requested value. Okay, the largest value that is less than or equal to the requested value. Now, what's this going to do? Well, suppose we looked up the original cumulative distribution probabilities here, and our random value happened to be 0.1. Perfectly respectable random value between 0 and 1. And if we got 0.1, then Excel's going to try and return the largest value from the list that is less than or equal to the requested value. Right, but our list, that is the list of probabilities, cumulative probabilities, does not have a value that is less than or equal to 0.1. So in order to use this approximate lookup, so-called, in VLOOKUP, we need to put another row on the front of our cumulative distribution function, basically a 0 row. So that's what we've done here. We've taken these values from the cumulative distribution function. I've copied them down here, and I've prepended a value for 0. And next to these, I've written the X values that might be returned, 0, 1, 2, 3, 4, 5. Okay, so another way of thinking of it is you take the X values exactly as they were and copy them in, and you shift the cumulative probabilities down by 1 row. Right, now you must use the cumulative probabilities in order, that is, they have to be sorted in ascending order. And now if we use VLOOKUP, and we do it on this, so we've got the appropriate table here to look up in, and if we have, as we see here, 0.38, then 0.38, the largest value that is less than or equal to 0.38 in the lookup table is 0.26, and so VLOOKUP will return 1 for that one, but now I've hit enter, and so it's changed the value, which it's going to happen for a volatile result. But now we have 0.25, and 0.25 is just a bit under 0.26, so it's going to return the largest value that is less than or equal to 0.25, which is 0. Okay, so this is going to give us the behavior that we want. So anything between 0 and 0.26 will return 0. And if we get a value between 0.26 and 0.61, then it should return 1, which is what we see. And I'll just do a few more to see if we get a bigger one. Here we go. Anything between 0.61 and 0.84 should return a 2, and that's what we see. Okay, so we're using the approximate lookup quirk, if you like, of Excel's VLOOKUP function. And this gives us quite a neat way to return values for an arbitrary discrete distribution where we don't have a mathematical formula for the probabilities, but all we have is essentially a list of possible values and the chances that they may occur. All right, so just to revise, you then produce the cumulative distribution probabilities. You shift that down by 1 row and you put a 0 at the front and put the original X values next to that. So for VLOOKUP, you must have the result column on the right of the lookup column. So we're actually looking up in the cumulative probabilities and we're returning an X value from column 2. All right, now with that in place, we can then go and get lots of values just in the same way that we did before. And just to explain the other thing that you see here, down here we have a frequencies table. This is giving us the X values, and this column is giving us the count for each value. Right, now we've only got 1 at the moment. We've got a 2 turning up, so we've got 1 of those. That's all we've got. And then the graph over here is giving us the column graph reflecting these frequencies. Okay, so let's go and get some more values. So we could get 10 at once, or as we've seen before, we can get any number at once. And so to get a really good idea of a distribution, let's try and go for 10,000. And you do need pretty high numbers pretty high numbers of observations generated in order to get something turning up in the low probability categories here. And so we do actually get a few turning up where the probability is quite low. And again, with a big number of observations generated, if we recalculate, then that histogram, the distribution, is relatively stable. Okay, so that's the last, we've finished that. That's the last in our series on simulation in Excel, this time for looking at how to simulate values from an arbitrary discrete distribution. Goodbye for now.